Thank you for joining me on the first of the level 3 problem set. What's going to change in these problems is that we're no longer dealing with individual forces acting on a lever. In fact, we are going to be having multiple forces acting on it. Now, in this problem set, we are going to be working with balances, kind of like a seesaw, like a teeter-totter. But in every case, you're going to be experiencing the balance being balanced. And so the first thing that we need to address is that when it's balanced, it means if I add up all the torques going counterclockwise to all the torques going clockwise, then we should get a net torque of equal to 0. And net torque is just the sum of all the individual torque values. So it could be like the first one plus the second plus the etc. So the first thing we're probably going to have to do is calculate some torque. So let's just get right into the problem right now. Number 7, calculate the mass of block A so that should be so that the two sides are balanced. So we need to figure out what the mass of block A is, and there's a question mark. And let's see what they gave us. They gave us 2 blocks. We got 2 distances. All right. So the first thing we're going to do is just calculate the torques we can. And the first one we can do, where we're not really missing any information to do it, is for block B. Now, block B has a mass, and as a result, assuming there's gravity, the gravity is going to act downward on it. And so we're going to have a perpendicular force acting, which is good. It means we don't need the sign of theta in this case. And the force of gravity is equal to the mass times the acceleration of gravity, which in this case will be 9.81. So I can now substitute so I know what my force is. I'm going to put my mass in, and then I'm going to put my acceleration of gravity. So the mass I have is 9 kilograms. And the acceleration of gravity is 9.81 meters per second squared. So as a result, if I plug and chug that into my calculator, I hit 9 times 9.81. All right. Turns out my old calculator I have is kind of dead. So there's this quick little delay as I get it up. 9 times 9.81 gives me 88.29 newtons. Actually, you know what? I'm going to make that blue. So now that I have my force of gravity, which is perpendicular, and I'm also provided a distance, I can calculate what the torque is. So we're going to say that the torque of block B is equal to the force, which is 88.29 newtons, times the distance from the force to the fulcrum, which is 1 meter. And because they're multiplying, I'm going to put some parentheses around it. And I don't even need a calculator. So we get that the torque of block B is 88.29 Newton meters. Now, I'm not finished yet. I still need to figure out which direction this is going, because the idea is that the rotation from B is going to counter whatever the rotation of A is and vice versa. So first, let's get the sign. I see that it is going, this way around, which is counter or clockwise. So that means that we're going to have a negative direction. Okay, so let's just go back to the beginning and let's see what we now know. I know the net torque has to be 0 because it's balanced. And that means that has to be equal to the torque of the first one, where we'll put A, plus the torque from B. And we already know now what torque B is because we just calculated it right here. So I can do a little bit of pre-algebra. A plus the torque of B. And if I subtract torque of B from both sides, these cancel. And what I get is that negative torque B is equal to the torque of A. And I know that torque B is negative 88.29 Newton meters. Makes these both positive. So that means that torque A has to be equal to positive 88.29 Newton meters. So now going back to block A, here's what we know. We know that torque of A has to be equal to the force of gravity for block A, which is perpendicular, and I can draw that right here, times the distance of A, which the distance between A and the fulcrum is 3 meters. And what I want to find is the mass, so that's going to be located somewhere within this force of gravity. So I can divide both sides by dA. What I get is that the torque from A divided by the distance for A has to equal the force of gravity. So now I can plug and chug. So my torque from A, we calculated, would need to be 88.29 Newton meters divided by the distance for A, which is 3 meters, and that's going to equal my force of gravity. So I go to my handy-dandy calculator, and I get 88.29 divided by 3 is 29.43 newtons. Now, I'm almost done. If they ask for the force, I could totally box that and move on. The issue is that they're asking for the mass. But this isn't really hard to find, because I know that from before here, that the force of gravity is equal to the mass of the block, which is what I want, times the acceleration of gravity. And I know the force, I know the acceleration of gravity, so I just want to find the mass. So I'm going to divide both sides by gravity. And what I get, too much red. I get that the force of gravity divided by acceleration of gravity is equal to the mass, which then I can plug and chug. We know that the force of gravity in this case is right over here. So I have 29.43 newtons divided by 9.81 meters per second squared. And when I plug and chug that into my calculator, I get 29.43 divided by 9.81. Ooh, and I get this really nice number of 3 kilograms, equaling the mass of block A. And I can box that and take that to the house. Now, before we move on, let's just check to make sure this is reasonable. I have 2 blocks, block A and block B. And block B is 1 meter, while block A is 3 meters away. So if block A is 3 times as far as block A is, that means that I only need 1/3 the distance. So when you get really good at this, you'll be able to do these kind of in your head and without doing all this work. But given that my higher mass has the lower distance, which is good, and my lower mass has the higher distance, that's great. If my distance on one side is 3 times longer than the other, then its mass would be 3 times smaller. So, all right, thank you very much.